All right, so this is the think and review questions related to a reduction in blood pressure. So we have the pathway slide here, we have the questions here, and then I've reposted the questions in the table here with the result of blood pressure and then the rationale. So make sure that you've attempted these ahead of time and then comparing your results here as we go through them together. So the first question is what would happen to blood pressure if you increase potassium exit from the arterial endothelial cells? The result would be a decrease in blood pressure. And the reason for that is you would have a loss of potassium. More potassium would leave, causing the sodium pump to turn even greater, causing more sodium to leave. At the same time, that's just going to cause a hyperpolarization of the endothelial cell, which is then going to cause the endoplasmic reticulum calcium channels to open, increase the amount of calcium would enter the endothelial cell, causing these special potassium channels, SK3 and IK1, to open, and then potassium would make its way into the myoendothelial intercellular space. And then you would have more of this potassium here, which would upregulate the sodium pump, causing potassium to enter, but more sodium to leave in the intercellular space. As a result, with the loss of the sodium and the recycling of potassium, that's going to cause the hyperpolarization of the vascular smooth muscle cell. With the hyperpolarization of the vascular smooth muscle cell, that's going to prevent the calcium channels from opening. Therefore, you have less calcium entry, a decrease in actin and myosin interaction, and therefore a decrease in vascular contraction. So the space for the blood to move through in the arterioles would widen, and therefore you would have a decrease in blood pressure. What about if you prevent calcium from entering the endoplasmic reticulum? So prevent calcium release, from the endoplasmic reticulum. Well, you'd have an increase in blood pressure, and the reason for that is by preventing calcium release from the endoplasmic reticulum, you'd have less calcium entry into the endothelial cell, which would prevent these potassium channels from opening. Less potassium would enter this intercellular space, and therefore less potassium to drive this sodium pump, therefore less potassium to drive this sodium pump, and therefore less sodium would be removed from the intercellular space. With less sodium removed, you would have the vascular smooth muscle cell would not hyperpolarize, and therefore these calcium channels would remain open, allowing calcium to enter. You would have an increase in actin and myosin interaction, an increase in vascular contraction, and therefore the narrowing of the lumen space of the arteriole, and less space for the blood to go through, and therefore an increase in blood pressure to help with that blood flow. So this would be an increase in blood pressure if you prevent calcium release from the endoplasmic reticulum. Number 3, what would happen if you turn off the sodium pump in the vascular smooth muscle cell and you close the gap junctions? So the same thing here is if you close the sodium, or you prevent the sodium pump from removing sodium, more sodium would remain in the vascular smooth muscle cell. That would then prevent the hyperpolarization, along with a reduction in hyperpolarization coming from the gap junctions. Therefore, you would have less hyperpolarization of the vascular smooth muscle cell, which would cause the calcium channels to remain open. Therefore, more calcium would enter. You'd have increase in actin and myosin interaction. You would have then a vascular contraction, a more narrow space for the blood to flow through, and a rise in blood pressure. What happens if you increase the EVM to 0? So you'd have the depolarization would occur in the endothelial cell. By doing so, then this would prevent the endoplasmic reticulum calcium channels to open. Less calcium would enter the endoplasmic reticulum. These potassium channels would remain closed, therefore less potassium inside the intercellular space, and therefore the sodium pump would not work as efficiently, so sodium would remain in the vascular smooth muscle cell. Therefore, the hyperpolarization of the vascular smooth muscle cell would not occur. Therefore, the calcium channels would remain open. Calcium would enter. You'd have increase in actin and myosin interaction, increased vascular contraction, so a narrowing of the space for the blood to flow through in the arterioles, and therefore a blood pressure would rise. So this is the thinking review questions for what happens in the arterioles. Make sure that you have a good understanding of this. Again, practice this, putting these in your own words and then comparing them to this. I'll put this video up on Blackboard along with the slides so you can compare your notes to them.